What's up, everybody? Welcome back to another wonderful video. So let's start this off with a little bit of a story. So after my randomized KH2 run that I did recently, that you can go and watch when I'm live on Twitch and YouTube, I went and rated a YouTuber streamer that I really enjoy, Nobody Daxian. Now Dax was doing a challenge of hitting the ball in the Grandstander job 9,999 times. Of course, as a chat, we were all having fun, coming up with data points, using our different degrees to help with the report, and even mock Ansem for not being as cool as we are. Now, as an engineer and a physicist, it led me to today's interesting question, which, you know what? Dax, how about you read it out for us?
Finding the gravitational acceleration in Kilohmz 2 would be really interesting. I never thought about how the ball drops versus the characters, etc. I mean, yeah, actually, I would watch that video.
So, how fast does the ball fall? To start this off, I probably need to give you guys kind of what's my position? Why can I tell you guys anything about Newtonian physics or Kingdom Hearts? I mean, heck, even let alone smash them together. Well, I have a degree in physics and mathematics from college. I taught physics, AP physics, and astronomy for 7 years. And I've been an engineer testing software for the last 2 years. Outside of all that, little flex right here, I predicted the main plot of Birth by Sleep to my buddy Pat almost 20 years ago after we watched the secret ending for the first time. And I know that it wasn't necessarily hard to do or anything, but I mean, it was 2009, all right? We didn't really know what online communities were. So that being all said, let's get into the meat and potatoes of it all. Note, there are some assumptions I'm gonna have to make in order to make life a little bit easier and to have a little bit more fun with this. First, I'm going to treat this like a high school physics class, meaning I'm going to ignore air friction because it's negligible and I'm lazy. 2, this is going to be done with mostly algebra, and by mostly I mean all algebra, because algebra is easier and I don't feel like doing the calculus. Second, I'm going to assume that the world of Twilight Town is a uniform mass and not a flat block of game-developed world. And lastly, that even though there's magic and all this other yada yada stuff going on, we're still going to try to compare this back, and it has comparable effects of the laws of physics that we know today. I know 2 and 3 are similar, but, well, just deal with it. I needed 3, it sounds better. Alright, so the first thing that we need to go over is the possible equations that we can use and which one seems best. Now, we have about 5 different equations we could use, or that could have an effect on things in motion. So we have the conservation of energy equation, and then we have what are kind of known as the 4 kinematics equations. Now, I'm going to toss out the conservation of energy equation, and I'm going to toss out 3 of the kinematics equations. This is going to leave us with this longest kind of looking equation. It's a quadratic, and it goes, basically, I don't have a good name for it, right? But it's x equals x initial plus v naught initial times t plus 1/2 at squared. Well, now that we have our equation, we kind of need to understand what each of the variables are used for. So x will be our end distance from our 0 point. X sub I will be our initial distance from our 0 point. V sub I will be our initial velocity, and t will be the time it takes for us to go from the initial position to the final position. A also being our rate of acceleration, or in this case, our gravitational acceleration, since we're doing free fall. Now that we know what all of these are, we have to pull everything properly into our equation so we can start solving it. We really need to gather the numbers. So let's knock out the 2 easiest ones right away, x and v initial. Both of these are going to be 0. Really easy, nice and simple. And you might ask yourself, well, why? Well, let's start off with x. It's a little bit easier to explain. If we look at the space we're going to, within this arena from Twilight Town, what we're going to do is we're going to use the ground as our 0 point. So when we smack the ball into the air, we'll use its highest point as our xi and the ground as 0, which will be our final distance. It's the final spot it reaches. Now, also in physics, the spot at which something's at the top of its arc, so where it starts to change direction, that is essentially at 0 for the tiniest millisecond of milliseconds. So at the top of our arc, which is where our initial x value is going to be, we also know that our initial velocity is going to be 0. And we can always refer to our variable table that I'm going to put up to also see these. Now, finding time will probably be the next easiest for us, because it's really just going to be how long does the ball take to fall from point A to point B. Now, there are a couple spots that you could measure this. Honestly, after kind of my testing and going back and forth, the easiest spot was really just for Roxas to hit the ball on the ground, see it get to its maximum point, and then kind of just time it for it to go all the way back down. When I did this and brought it into DaVinci Resolve, not sponsored, but I do love the software, and if you're getting into editing, it's very helpful. I set a timer up with it, which I found, and I can link the video below that I learned how to make the timer. But I set the timer at 0 right when we started this clip and let it run out until the ball hit the ground. And I found out that the time it takes for the ball to go from that height all the way to the ground is about 1.2 seconds. That being said, let's go ahead and update our variable table. All right, last, we only have 2 variables left that we need to talk about. We need to talk about what is x initial and the acceleration. Now, x initial is probably going to be closer to a guess than actual measurements. And part of that's going to be from the images that you see up on the screen right now. I know that if we were going to use Roxas as a standard measuring unit, so from the tip of his hair down to the bottom of his feet, which is about 160 centimeters or 1.6 meters, or about 5'2" to 5'3", then that kind of gives us the idea based on, from multiple sources getting this, we can use that to kind of reference and scale things and kind of determine what the height is going to be using Photoshop. So with that information that I just talked about, we take this screenshot of where the ball is at the top of its arc and kind of took a couple of photos to make sure we could get it as best positioned as we could. And we kind of see that it's about the bottom of the window. Using Photoshop, we can actually use the ruler tool to measure things in there, and we can measure to get out what the total amount of units it is to get up there. Then with some converting, which I'll kind of, if you want to pause and read through it, you can kind of read through my conversion that I used. But basically the long and short of it is, we know that the top of the top bottom part where the ball hits on the window, we know that that's about 3.296 meters or 10.812 feet, plus or minus a missing link. Please, Square, we're really looking for more information on that game, and we would love some as soon as you can give it to us. That aside, let's go ahead and update our variable table, which leaves us with our last single variable that we need, the acceleration. So since we're looking at the rate at which the ball falls, we are looking for an acceleration. Now, the acceleration is due to the gravitational pull of a celestial body. In this case, it's the programmed value for Twilight Town. And in all honesty, it's probably the same across all of the other worlds in Kingdom Hearts. I don't know why they would try to change it. It's not like No Man's Sky where you're having different bodies and different sized planets. So to find this acceleration, I'm going to go back to the equation that we said we were going to use. We're going to do some algebra to manipulate it around so that way we can solve for the variable A. So first, I'm recording this a couple days later. I know that I've said X a lot in this video. And if you guys didn't see the note, X and Y are very interchangeable. It's just one's vertical, one's horizontal. So yes, since we're dealing with the vertical direction, I've been using Y, and I had like postscript clarity on that, and I'm very sorry. So, but flame me for it in the comments, it's funny. Anywho, let's walk through how we solve this equation for A. So we have our long equation, y equals y initial plus v initial t plus 1/2 at squared. Now, our y is going to be 0, and our initial velocity we already know is going to be 0, And we're not going to put in any more variables right now just because we'll do that here in a second. So that cancels out. Anything times 0 is 0, leaving us with 0 equals y initial plus 1/2 at squared. So to get a by itself, we have to move y to the other side, giving us negative y initial equals 1/2 at squared. Next, to get rid of the 1/2, we have to multiply by 2. If we do it on one side, we have to do it on the other. So that'll cancel it out there and give us negative 2y initial equals at squared. And lastly, we got to get t away from a. So we divide that out to get them to cancel, leaving us with, and we'll write it in a different color for it to be fancy, with an equation of a equals negative 2y initial over t squared. So now that we have that, we can take the last two variables we have and we can go ahead and we can plug and chug and get this all cleared out for us. All right, so now we can just go ahead and plug and chug, which means that we need to put in all of our variables. So we have negative 2, our y initial was 3.296. We have all of that over 1.2 squared. Now, when I like to solve these when I was teaching, I used the TI-84. That's what we had in the schools. And so there's a alpha y equals. You hit the alpha button and y equals, and it pulls up basically like a nice little template that you can actually build your entire equation and punch it in like this. In lieu of that, the other way to go ahead and do it is just to do the top, then do the bottom, and then divide it on out. So up top, we're gonna have negative 6.592. And on the bottom, that's gonna be 1.44. So we go ahead, we take these two guys right here. We're gonna get negative 4.57 repeated meters per second squared. Now, the negative doesn't matter as much. The negative, that's really just the direction. And so that's just telling us that it's going down. But yeah, there we go. I'll go ahead and pass it back on over to Scripted Me to finish this on up. Awesome. So our gravitational acceleration for the ball comes to 4.57 repeated meters per second squared, or 15.019 feet per second squared. Now, the gravitational acceleration for Earth is about 9.8 meters per second squared, or 32.174 feet per second squared. This makes the rate of acceleration at about half of what it is for us here on Earth, which leads to some interesting thoughts about how the muscle development of humanoids are in Kingdom Hearts. Probably some of that magic and other yada yada. I don't know. I'm not a biologist. I won't even assume to try to figure out how the muscle really develops. Now, that all being said, I want to thank you guys so much for watching and making it to this point in the video. I really appreciate you guys taking the time to go through this journey with me. If you enjoyed it, please like, subscribe, comment. I'm looking for more ideas like this. I do like using my physics degree, but I don't know necessarily what some of the cool questions are to ask all the times. I just kind of go with it. This was a lot of fun. Took me a couple days doing some research, some playing around to kind of figure stuff out. And heck, even if you guys want to see more of that process, maybe I'll be able to stream it or something. So if you guys like it, again, please subscribe, please like, please comment. That lets me know that what I was doing was making good content for everybody. This is my first one of these. So please, again, let me know what you'd like to see next. Let me know on ways you could see this improve. You know, I like to record a lot of my content live on Twitch and on YouTube. But as I've said that a bunch of times before, and I've ranted enough, I hope you guys have a great and amazing day. I'll see you guys in the next one. Adios.